Good afternoon, everyone. All right. So, in our last lecture, we dealt with our circles chapter. Yes, the last two sessions were about circles. Now, let's quickly move to the next chapter, which is some applications of trigonometry. Like, okay. So, like the name says, it's applications of trigonometry, right? So, trigonometry is going to play a major role in this chapter. So I believe you're done with your basics of trigo. You also had some revision session for trigonometry, right? So I believe you're done with the basics of trigonometry, and we can go ahead with this chapter. Okay. So people, before we begin with this chapter, make sure you do these sums very well, because these are the 4-mark sums which you get in your paper, right? These are mostly the 4-mark sums which you get in your paper. So make sure that you understand how to deal with this chapter really well. Now, like I said, it deals with trigonometry, but that is not the tricky part. If you know your trigonometry basic concepts well, a slightly tricky part in this chapter would be understanding how to draw the diagram. So the major focus is going to be on how to draw the diagram and how to get your trigonometric ratios right. Yeah, once you get the trigonometric ratios right, substituting and doing the math is not really difficult, I believe. Right, so quickly we're going to go ahead and start with this chapter. Now, before we move to doing some sums in this, first let's try to understand, why do you even need to study this? Oh, why does this chapter even exist in your syllabus? Why do you need applications of trigonometry, students? So pay attention. Whenever you have huge figures, like suppose you have to find the height of the mountain, or say the depth of the river, yeah, or say the width of the river, or the depth of the river, right, or say the height of the Eiffel Tower. If you look at any of these, the usual way to measure distance is, say, using some measuring tool, say a measuring tape or something like that. But if you look at these huge structures, there's no way you can measure this with any measuring tool, right? That's just not possible. So for such figures, what you do is, we always consider a right angle triangle. Now, whenever you talk about structures, any geographical structures, you have to always consider them to be right angles, right? They have to be perpendicular to the ground, which is why we talk about right angle triangles. And what's the best way to deal with right angle triangles other than trigonometry, right? Trigonometry is a study which only deals with right angle triangles, which is why we're going to use trigonometry to solve such issues dealing with such huge structures. All right. Okay. So now that we know where we are going to apply this, let's quickly move towards some basics. All right. Now, some basics, some important points that you need to know before you move to your sums. All right. Now, these points are extremely important. They play an important role because they'll be the use terms in your sums. These are the exactly the same terms which are going to be used in your terms, in your sums. So please pay attention. Let's look at each of them one by one. The line of sight. Yes, the name itself means line of sight. The line where you're seeing, right? So, what does the line of sight actually mean? Now, if you observe, there's this boy and he's looking at the cow, whatever that is. Yeah, it's like a cow. So, there's an imaginary line which always goes from your eye straight to the object, right? Whenever you're looking at something, it's not like your vision keeps bouncing around and then goes to the object. It hits straight at the object, right? So it's an imaginary line from the observer to the observing point. Yes, that is always known as the line of sight. So let's quickly observe. So now if the observer changes the object that he's looking at, so pay attention, now the object is the door. So observe this, the observer is the same, so the starting point of the line of sight is the same, but now the object is different. The observing point has changed, so the line of sight changes its direction. If you look further up or down, then again the line of sight goes down, right? But the observing point still remains the eye of the boy. Or say up at the apple, still it's the same thing, line of sight. So line of sight is nothing but the line between the observing point and the point where we are looking at the object. So it's the observer to the object. That is what you need to remember when you draw your diagrams. It's the point of observation to where you're observing. All right, let's quickly move to the next term. Next term is angle of elevation. Now, as the name says, it's angle, right? An angle of elevation. Elevation means at a height. Yes, Elevation always means at some height. Elevated is at a height. So now what is this angle of elevation? Now students, pay attention. Angle that we are talking about is always going to be the angle that the line of sight makes with a horizontal line. Yes, line of sight makes with a horizontal line. So now first let's try to understand what horizontal line is. Horizontal line is just any line which is parallel to the ground. Now, why do you need a horizontal line if you already have a ground? Suppose your line of sight or your object is at a height. Yes, then you need a horizontal line which is parallel to the ground, which is why you always need a parallel line or the horizontal line. Now, once you know what a horizontal line is, let's move to the angle of elevation. Angle of elevation or angle. Basically, angle that we will talk about is angle that the line of sight makes with the horizontal line. So let's first have a line of sight. Suppose I'm going to look at the top of the tree. Yes, this boy wants to look at the top of the tree. Again, from the observing point to the object, that imaginary line is the line of sight. And the angle, students pay attention, the angle that the line of sight makes with the horizontal is theta, which we're talking about. Now, so when do you talk about elevation? Elevation is when the line of sight is above the horizontal line. Yes, the line of sight has to go above the horizontal line. It's at a height. That means it's angle of elevation. Yes, so again, angle of elevation is angle made by line of sight with the horizontal line. And in general, it's denoted with theta. Yes, so we denote theta as the angle of elevation. Let's move to the last part, which is the angle of depression. Now, students, angle, the definition of the angle would remain same, line of sight with the horizontal line. What changes is depression. Depression means at some depth. At some depth, or in general words, below. Yes, in general words, for this, it means below. So it's very easy to understand. Now look at this boy. He wants to look at the flowers, right? And pay attention. He is now from the door, he has gone to his balcony. So he is at some height. So first thing you need to do is draw a horizontal line. Whenever the observer is at any height, draw a horizontal line. Angle is always horizontal line with the line of sight. So this is the angle that we are now talking about. And since it is below the horizontal line, like I said, since it is below the horizontal line, we call this as the angle of depression. Yes, depression means below. So line of sight is now below the horizontal line. Again, it's the same angle theta, and the angle is again between line of sight and the horizontal line. Yes, so the only difference between depression and elevation is line of sight above the horizontal line. Depression is line of sight below the horizontal line, but the angle is always made with the horizontal line. So let's see all four concepts now in the same slide. So let's see all the four concepts. Okay, so we have a horizontal line because the observer is at a height. Now, if he wants to look at the bird, from his eye to the bird is the line of sight, and since line of sight is above the horizontal line, this is angle of elevation. Okay, so I'm using the short form AOE, angle of elevation. Now, from the same point, the point of observation has not changed. If he looks at the flowers which are below, again, this is theta, angle made by the line of sight with the horizontal line. But now, line of sight is below the horizontal line. So this is angle of depression. Yes, the angle made with the horizontal line and the line of sight, but below the horizontal line is the angle of depression. So I hope you have understood all these four important points, because they are going to be used, these terminologies are going to be used in your sums. Now, apart from these important terms, there are a few rules which you need to follow when drawing the diagrams for these sums. First important rule, all the heights of objects, towers, trees, buildings, anything that you take are going to be perpendicular to the ground. So we are not going to consider any leaning towers of Pisa out here. Unless and until it's told, we are going to consider all heights of structures to be perpendicular to the ground. Okay, so that means we are definitely going to have right angle triangles. Now, the next important point is Okay, so observe trees, buildings, all these are perpendicular to the ground. Now, next important point is height of the observer. Now, in this case, the observer is the man out here. Yes, height of the observer is going to be neglected unless it is specifically given. So, unless they tell you that the height of the man is 1.5 meters, we're going to neglect this height. Why? Students, if you observe, we are talking about very extremely tall structures, right? Say, for example, the distance of this helicopter from the earth. Now, that's going to be a huge distance. It's going to be in kilometers. So, definitely, we can neglect this 1.5 meters, right? Which is why, unless and until they give you the height of the observer, you're going to consider it to be a point object on the ground. Consider it to be a point on the ground. So this man, we are actually going to talk. So this man is not going to observe from the eye, it will actually observe from the ground. Yes, is that understood? So this is what we are going to always consider, the man to be a point object unless the height is given. And these were some important rules to consider. Let's quickly move towards the sums. Students, like I said, I'm going to focus more on how to draw the diagrams because students mostly face difficulty while drawing the diagrams. So we'll focus on that. We'll try to draw the diagrams from the scratch. Okay, let's pay attention. A circus artist is climbing a 20-meter long rope. Okay, so we have a rope and the length of the rope is given, but we cannot say anything about the rope, if it is inclined with the ground or if it is perpendicular to the ground. We don't know anything about the rope. So let's keep moving ahead till we find something concrete, which is tightly stretched and tied from the top of a vertical pole. Now, students, in a right angle triangle, we know there can be only one height. And they have already told us there is a vertical pole. That means this pole has to be considered perpendicular. Okay, don't mind the diagram. It's a freehand drawing, so don't mind the diagram. So the pole has to be vertical. Now, if the pole is vertical, the rope cannot be a vertical line. What is said, this rope is tied from the top of a vertical pole. That means this rope is tied from here. Now, from here, if it is tied, it has to go down like this, right? Because from here, it is making an angle with the ground. Yes, the angle made by the rope with the ground. So the rope goes from the top to the ground, and the angle that they are talking about is this angle, which is 30 degrees. Now, definitely, we can join the rest of the figure so that our right angle triangle is complete. Don't forget to mark this right angle. Now let's talk about the things that are known to us. We know that it's a 20-meter long rope, and our rope is, let me name this figure for you. So our rope is AC. That means AC is 20 meters. Yes. What do we have to find? We have to find the height of the pole. That means in our diagram, we need to find AB. Once the diagram is neatly drawn, once you're sure of your right angle triangle, then it becomes a cakewalk, students. Pay attention. Now it's a right angle triangle. Trigonometry is taught to y'all. In trigonometry, you already know that when theta is given to you, in this case, theta is 30 degrees. When you have theta and at least one side of a triangle known to you, then you can safely find the remaining two sides as well as the remaining angle. You can find the remaining two sides and then you can find the angle as well. The remaining angle, by that I mean angle A. But right now we are not concerned about angles. All we are concerned about is side AB. So let's quickly look at the figure. Let me take this geometric figure. So this is what we have. I'm going to take this as our geometric figure. So as you can see, AC represents the rope and AB represents the height of the uh, tower, right? We had a pole out here. Yes, so AB represents height of the pole. Now students, pay attention. How does trigonometry play a role out here? What we have is we have theta out here. Now, for this angle C, which is theta, always we have to take a ratio of one thing that is known and one thing that you have to find. Yes, so definitely we will have to take a ratio of AB and AC out here because AB is unknown to you and AC is known to you. Students, pay attention. For this theta, what kind of side is AB? Quickly. For theta, AB is which side? You have only three options. It's either opposite, adjacent, or hypotenuse. So only three options: opposite, adjacent, or hypotenuse. Okay, all right, okay. I'm getting answers. Yes, thank you so much, people. Yuvraj, Vedant, yes, Ajay, thank you so much. Others as well. All right, yes, Sharnav and Parth. Yes, it's the opposite side. So we know that AB is the opposite side. Yes, and AC is the hypotenuse. Yes, definitely AC is the, oh, Prathamesh, opposite. Yes. So AC is the hypotenuse. And students, we know that opposite upon hypotenuse is a very special kind of a ratio in our trigonometry, and it is known as the sine ratio. Yes, opposite upon hypotenuse is known as the sine ratio. Now, since this is the sine ratio, obviously we are going to take sine of this angle. So, what are we going to do? We will take sine theta as opposite upon hypotenuse, which is AB upon AC. Now, students, why do we do that? We know sines of all standard angles, right? So whenever there's an angle given to you, you can find sine, cos, tan, sec, cot, cosec, anything of these standard angles. And if they are not standard angles, you need not worry. You will have the table given to you. You'll have the trigonometric table for non-standard angles given to you. So now, sine 30. Quickly, let me see who remembers this. Sine of this very simple angle, sine 30. What's the value of sine 30, people? Quick, so that I can go ahead. Yes, that's half. Yes, Prathamesh, thank you so much. Yes, Yuvraj, that's correct. It's half. So we all know sine theta, which is sine 30, is half. We don't know the value of AB, so let's keep it as it is. And AC we know is 20. So the reason we have taken this ratio is we know sine theta, we know AC. There's only one unknown. One unknown can be easily dealt with. Now you can solve this. I'm not concerned about the solving part. That's pure algebra. So we'll just quickly see. Yes, half is equal to h by 20. If you want, you can cut 2 and 10, 20 right out here, 1 and 10, and then just cross multiply, right? So h is equal to 10 meters. That's an extremely easy calculation. Calculations you shouldn't be worried about. What you should be worried about is getting till this point. Identify the ratios properly and especially the diagram correctly. Once you're done with this, students, I'm very sure this is not difficult for you all. All right? Okay. Now, another important thing which students usually tend to miss is description. Students, there are marks for description. Please don't forget this is your diagram, right? So if the diagram is yours, you need to describe your diagram. So nothing fancy, just something which you just need to describe the important points, right? For example, out here, since we're using a ratio of AB and AC, AB and AC are the important points. So just say AB denotes the height of the pole, AC denotes the length of the rope, and equal to 20 meters, whatever is given to you, just mention that much. That's it. You don't need some Mahabharat or anything out here. Just some simple words, and then you can go ahead with your sum. All right. Any issues with this understanding, students? Also, you can let me know if anything is not understood or if I'm fast. For any of the above reasons, you can let me know. Okay, all right. Since you have no issues, we can move ahead. Okay, so I would request you all not to look at the diagram if it's already given to you, because we're going to try and draw the diagram from scratch. Okay, so let's see what do we have out here. A kite is flying at a height of 60 meters above the ground. Now, students, pay attention. We are going to consider the kite to be a point object. Now, since the height of the kite from the ground is given, height is always perpendicular distance. So from this kite, first thing I'm going to draw perpendicular to the ground. Now, since we have the ground, the base we can draw. What else do we have? The string attached to the kite is temporarily tied to the ground. Now, students, you know when you fly a kite, the kite never goes straight, right? The string of the kite always makes some angle. So this has to represent the string of the kite. So what do we have? AC is the string of the kite and AB is the height of the kite from the ground, which is known to us. It is 60 meters. So AB is 60 meters. And what do we have to find? Inclination of the string with the ground. AC is the string, its inclination with the ground theta is 60 degrees, and we have to find the length of the string. We need to find AC. Yes, is that understood? So I would request you all not to look at the diagram even if it's given out here, because we're going to understand from scratch how to draw it. Okay, so you don't have to worry about anything. We'll see how to go about from the start of the sum. Now, what is said? Find the length of the string assuming that there is no slack in the string. Students, slack just means some folds. So we're going to assume that the string is taut and there are no folds in that string. Okay, so basically it's just a straight line. Okay, so that is what this means. Now let me take this figure. Again, an extremely simple sum. Now students, pay attention. Theta is angle C, 60 degrees. For this angle C, there is one side known to us and one side unknown to us. Definitely you need a ratio of these two sides. So if you need a ratio of AB upon AC, if I say that AB is the opposite side again, and AC, as we know, is the longest side, hypotenuse. And this means we are talking about the sine ratio. That means sine of 60 degrees. Now, sine 60 is equal to AB upon AC. You should know the value of sine 60. AC we know. So AB you have to find. Yes, that's correct. Okay, students have already given me root 3 by 2. That's perfectly correct. Sine 60 is root 3 by 2. Students, I hope you know how to draw the table for standard angles by now. The moment you enter your paper, students, during the examination hall, the moment you enter, first take the paper at the back side. Please draw this table according to the steps that are known. All right. I mean, I'm sure you will remember the values, but drawing this table is going to be extremely handy for everything. Okay. So now we know sine 60 is root 3 by 2. We know AB. AB is 60, and BC, sorry, not BC. We need to take AC, which we don't know. Okay. You can cross multiply, handle this. Before I move ahead, one extremely important point. Students, we have taken a ratio of AB upon AC, right? I could also take, okay, it's not equal to sine, but I could also take a ratio of AC upon AB. Quickly tell me, what is this ratio, AC upon AB? With respect to angle 60 degrees, with respect to our theta, what is the ratio AC upon AB? So let's quickly see. Okay, I see a sec in between. Okay, yes, others cosec. Yes, so you're right, it's not sec. Sec stands for secant. So it's not sec, it's the cosec ratio. That's correct. It's the reciprocal of sine, and that is cosec. But in applications of trigonometry, I would prefer that you keep your ratios to the primary ratios and to tan. So basically, only use sine, cos, and tan. Do not go for the secondary ratios, sec, cosec, and cot. Yes, so we're gonna keep it simple, sine, cos, and tan, which is why I would stick to this ratio, opposite upon hypotenuse. Now, quickly we can solve this. What do we get? We get 60 into 2 upon root 3. Students, I'm not concerned with the calculations, but one thing you need to understand, your irrational numbers should not be there in the denominator. So the moment you come across an irrational number, you know what to do with it. Just rationalize, right? So what you do is multiply and divide by root 3. We do this because root 3 upon root 3 is 1. So basically we are not doing any operation. So this is just to get rid of this root 3. Yes. So now what do we have? Root 3 into root 3 is 3. So we have 60 into 2 into root 3 upon 3. You know, 3 and 60 would cancel. That leaves us with 20 into 2, 40 root 3. Yes, that leaves us with 40 root 3. And students, you do know the value of root 3, right? So please substitute that. Irrespective of whether it's given in the sum or not, you always know the value of root 3 is 1.73. Unless they give something else, they could give you either 1.7 or 1.732. Unless mentioned, take up to 2 decimal points and multiply with your answer and get the final answer without your irrational number. Yes, so make sure you always do this. Another root which could come, a probability of that root is root 2, whose value is 1.41. So these standard roots, you know their values. So please directly substitute them and don't leave your answer out here. Okay, you might lose your marks for doing this. Okay, units is another important thing which you need to remember from point of view of writing. And for your word problems, your final answer has to be in words. Okay, so do not forget these small tricks because these are extremely important things. You'll simply lose half mark for these silly mistakes. Okay, so we move ahead to the next sum. I believe you shouldn't be having problem with these sums. They're extremely easy. Now, let's move to this sum. A contractor plans to install 2 slides for the children to play in a park. So we just have 2 normal slides. Now we know a slide is a slant line, right? So we are going to consider the slide to be the hypotenuse. The moment you look at the sum, you need to understand who's going to be what in your right angle triangle. So definitely a slide is a slope, so it will be your hypotenuse. Next, what do they say? For the children below the age of 5, she prefers to have a slide whose top, so we're talking about the top of the slide, and top is at a height of 1.5 meters from the ground, obviously. Now, Top of the slide is 1.5 meters from the ground. Height, like I said, is perpendicular distance. That means your height is 1.5. Yes. Now let's just quickly join the rest. So we have just joined the rest, and I'm going to have A, B, and C out here. Okay. Now this top is also inclined at an angle of 30 degrees to the ground. So this slide is inclined at an angle of 30 degrees. Yes, your theta is 30 degrees. Now, extremely easy sum, right? Students, what do you need? You need to find the length of the slide in each case. So students, we have two different slides out here. One for the younger child, one for the elder children. For the elder children, theta is 60 degrees, height is 3 meters. For the younger children, we have 30 degrees and 1.5 meters. So it's both the slides look kind of similar to each other. So let's solve only for the first slide. The second slide, I'm sure you can manage, right? Okay. Quickly. Now, you're directly going to tell me which ratio are you going to consider to find AC. Come on. Now we've already seen how to gather our ratios, what sides should be a part of the ratio. Okay, part says sine, small side of 3. Okay, okay, half sine. Okay, so that's correct, right, students? For this angle now, one thing we know is opposite side is known to us, and hypotenuse we need to find. And opposite upon hypotenuse we know is sine. So definitely we are going to consider sine ratio. Yes. So that's it. Now it's so easy. The calculations are extremely easy. What we do is sine 30 is AB upon AC. Half is 1.5 upon, take it as X, keep it as AC, doesn't matter. At least for the less complicated sums, if you don't take it as X, it's okay. But when you have more than one triangle, it's imperative that you use a common variable. For this, it's just 1.5 into 2, 3 meters, right? So the same way you're gonna get this equal to 6 meters. Yeah, it's just the same ratio. So simply you can get PR equal to 6. So I'm gonna waste any more time on such sums. Let's quickly move ahead. Okay, all right. So we're gonna quickly move ahead. Okay, students, pay attention now. Angle of elevation of the top of a tower. The moment you realize there's a tower, there's a structure, a building has to be perpendicular to the ground. Okay, so we drew a perpendicular for the tower. Let's name it AB. Next, what do we have? From a point on the ground, which is 30 meters away from the foot of the tower. First thing, we have a point on the ground. Let's mark that point as C. Now, this point is at a, ignore. This point is at a distance of 30 meters from the ground, from the foot of the tower. So from B, distance of C has to be 30 meters. Yes. Next, what do we need? Also, the point, so pay attention, angle of elevation of the top of the tower, angle of elevation of the top to the point on the ground is 30 degrees. So we have our theta also out here. Theta is 30 degrees. We need to find the height of the tower. That means we need to find AB. Now, students, pay attention. Let's quickly move to the diagram. We know that BC is 30 and we need to find AB. Now, pay attention. Again, for our angle 30 degrees, there's one side unknown AB and there's one side BC which is known to us. Again, for theta, AB is the, what side is it? Opposite adjacent hypotenuse. AB is, yes, students, quick. Okay, so it's the opposite side. And the side which is known to us is BC. What is BC for our theta? Side BC is? Okay, Yuvraj says adjacent side. Okay, all right. Others? Yeah, thank you so much, people. Yes, Vedant, that's correct. It's the adjacent side. So now we know for our angle, one side is the opposite side, the other is the adjacent side. That means the ratio we are talking about has to be this, right? It has to be opposite upon adjacent, and we know opposite upon, yes, that's correct, Sharnav. Yes, Yuvraj, that's perfect. Opposite upon adjacent is tan ratio. So we need to take tan, and tan of which angle? Tan of 30 degrees. Now, tan 30 is again opposite upon adjacent, so let me write AB upon BC. Quickly, tan 30. Yes, students, let's see if you remember. 1 by root 3. Okay. So my students have done their homework. I'm extremely happy about that. That's correct. It is 1 by root 3. Yeah. And if you ever forget, tan can also be written as sine upon cos, right? Do not forget your basic trigonometry. It can also be written as sine upon cos. Sine 30 is half and cos 30 is root 3 by 2. Your 2 and 2 get cancelled. What remain is again 1 by root 3. Okay, so let's move ahead. 1 by root 3 is AB upon 30. Again, you get the value of AB to be 30 upon root 3. So let's quickly look at the calculations. They are supposed to be extremely easy. So what do you get? You get the height as 30 upon root 3. Irrational number in the denominator calls for rationalization. Do your math. Once you get root 3 in the numerator, multiply by 1.73 and get the final answer. Okay, final answer, again, write it in words. So I'm not concerned about the calculations. Your math, you can do that well, I'm sure, right? Multiplication is not such a difficult job to do. Okay, so we move ahead to the next sum. Okay, now students, please pay attention to this sum well. A tree breaks due to storm and the broken part bends so that the top of the tree touches the ground, making an angle of 30 degrees with it. Okay, a whole lot of information in one sum. So let's quickly break this in bits and pieces. First of all, we have a tree. A tree, it's a structure. A tree has to be perpendicular to the ground. Okay, so I have a perpendicular drawn. Next, students, pay attention. A tree breaks due to storm and the broken part bends. So first thing, we need to fix a point. So let me name this tree as AB. Now I'm going to fix a point C where the tree is going to break. It's not told that it breaks at the midpoint or anywhere. So just fix some random point. Say this point C. Okay, so at C, this tree is breaking, and now the broken part is BC. So it's pay attention, there's a difference between breaking and uprooting. The tree is not getting uprooted, so it is not going to fall from A. It's breaking at some point C, and from this point, this part BC is now falling to the ground. Yes, the broken part is now touching the ground. And what does it say? That the top of the tree is now this point, right? This point, this top of the tree is making an angle 30 degrees with the ground. So the top makes an angle of 30 degrees with the ground. Now there's only one point remaining which is not joined. Join the base. Let's call this point D. Now you need to find the height of the tree. Before that, what do we have? Distance between the foot of the tree. Foot is at point A and to the point where the top touches the ground. Point where the top touches the ground is D. So the distance between A and D is 8 meters. That means what we understand is AD is 8 meters. We need to find the height of the tree. Students, understand, we need to find the height of the tree. That means we need to find AB. Okay, I'm just going to change the color so that this is more evident. Yeah, so we need to find AB. But if you pay attention, look at AB. AB does not form a part of your right angle triangle. AB is divided into two parts, AC plus BC. Now, AC belongs to this right angle triangle, so you can find AC. We will look at that how. BC does not belong to the right angle triangle. But if you understand, this is the same broken part, right, which has fallen to the ground. So what we know is BC is equal to CD. So instead of finding BC, we are going to find CD and then replace CD with BC in our formula and calculate AC plus BC. So now let's quickly move ahead to our question. So now we have understood we have to find AC as well as CD. Okay. Now pay attention. Again, that's no big deal. Like I said, if in a right angle triangle, you have theta known to you, okay, if you have theta known to you, and you have at least one side of the triangle known to you, you can find the remaining two sides. So you can very easily find AC and CD, but you need two ratios for that. Quickly, first we're going to look at AC. Now, quickly tell me, to find AC, what ratio are we going to consider? Yeah, students, okay, I see tan. All right, so tan. Okay, students, let's see if we can apply tan ratio. So for angle D, which is angle 30 degrees, let's see. We have to find AC, which is the opposite side. And there's only one. Yes, thank you so much, Yuvraj, Shavnav, Prathamesh. That's correct. We have to find the tan ratio because the ratio is between the opposite side and the adjacent side. And that we know is tan. So we will find tan of 30 degrees. We all know tan 30 is 1 by root 3. So 1 by root 3 is AC upon AD. AC we don't know, and AD is 8. So AC is going to be 8 by root 3, multiply and divide by root 3. Now students, one extremely important step out here. So what we're going to do is, let me just take you to that. Okay, so AC is 8 by root 3. Students, at this point, you can either leave it like this or rationalize it. Once you rationalize it, what you understand is you will get into root 3 upon root 3. Yes, and that is going to get you to 8 root 3 upon 3. Now, we all know 3 and 8 cannot be cancelled, so do not bother about cancelling them. Please understand this is not your final answer. Finding AC was not the motive. The motive is to find AB. So do not cancel anything. Leave it like this, and we will see what to do with it at the end. So you can either rationalize and leave it, or you can leave it before rationalizing also. There's no problem. Leave it as 8 by root 3 because it is an intermediate answer. So because we cannot cancel 8 and 3, you should not go ahead. All right, let's see now what we do with the rest of the sum. We have to find CD. Now there are two ways to find CD. You already know that AC is 8 by root 3, but I'm sure you wouldn't want to deal with this number. But if you deal with AC and CD, if you take a ratio of AC and CD, what ratio do you think you can consider? Students, what's the ratio of AC and CD? Okay, I see cos. But I want to know what's the ratio of AC and CD first with respect to our theta. Ratio of AC and CD. Yes, students? Come on, quick. We'll get to what we need to do, but there's another possibility taking a ratio of AC and CD, which is sine. That's correct, which is sine. But I'm sure you wouldn't want to deal with this number. So we'll just let that be. And we're going to use AD. Now, we're going to use the ratio of AD, which is known, and CD, which is not known. AD we know is the adjacent side. CD is the hypotenuse. And that means we're talking about the cos ratio. Yes, as you all pointed out correctly, we are talking about the cos ratio. So you can talk about that. But this also won't be wrong. AC upon CD, you can safely take sine as well. So let's look at cos. Cos 30 is AD upon CD. Quickly, cos, yes, as Parth rightly said, cos 30 is root 3 by 2. So root 3 by 2 is 8 upon BC. What we get is BC is 16 by root 3. Now, students, pay attention. This gets so easy, right? AC is 8 by root 3. BC is 16 by root 3. And we need to add AC and BC. Root 3 is a common denominator. So let's add it in this form itself. Yes, we have a common denominator. So you just need to add 8 plus 16, which is 24 by root 3. Now you can safely rationalize it because obviously this is the final answer. So let's quickly rationalize that into root 3 upon root 3. So you can cancel the rest, 8 root 3, substitute the value of root 3, get the answer. This is the height of the tree. Yes, always students do not directly substitute values. Do not miss important statements which have to be written. All right, so you have to first mention this. I know, I mean, this looks like an extra job, but you cannot do anything. You need marks, right? So yeah, you have to do this and then substitute. Always substitute once you put in the formula. Okay, any issues with this sum? Anything that's not understood? Also, let me know if I'm going a bit too quick. I believe these sums are already done and you're done with this chapter. So we can go a bit quick, right? All right. Okay, so we move ahead. All right. So students, let's look at the next sum. Okay, from a point on the ground. The moment you read everything which is going to be important, students, start plotting it in your diagram. So what do we have? We have a point on the ground. Angles of elevation. We're talking about angles. We have more than one angle. Let's see which are those two angles. Angles of elevation of the bottom and top of a transmission tower fixed at the top of a 20-meter high building. Okay, students, now here we have two structures. There's a building, and on top of that, there's a transmission tower. So let's do one thing. First, let's have a height for the building. Okay, so we're gonna have our building as AB, and on this building, now there is a transmission tower. So let's call our transmission tower BC. Okay, now let's look at those two angles again. They say angles made are to the bottom and top of a transmission tower. Students, bottom of the transmission tower is at point B. So from the point, we need to join the bottom of the tower, which is point B. And from the same point, the point of observation hasn't changed a bit. So from the same point, we are also gonna look at the top of the transmission tower. That's how we have two angles. Now it's extremely obvious, students. The smaller angle is going to be angle BDA. Yes, angle BDA is the smaller angle. So the smaller angle theta, which is 45 degrees, is for BDA. And the bigger angle 60 degrees is for angle CDA, which is 60 degrees. So pay attention, you have two angles, mark them correctly. Do not go wrong with these angles. Apart from that, apart from this, what else do we know? We know that it's a 20-meter high building. Okay, so what we know is AB is 20 meters. Any other information that we are missing? No. So this is all the information that is known to us. We have two angles and one theta. Now students, pay attention. Like I said, whenever there are more than one right angle triangles, that's when you need to pay utmost attention. We need to find the height of the tower. That means we need to find BC. Now, if you look at BC, first and foremost, BC belongs to which triangle? BCD. Yes, BC belongs to a triangle BCD. But if you look at triangle BCD, it is not a right angle triangle. Is BCD a right angle triangle? No. So if you have to find BC, we cannot consider any ratio in triangle BCD. So now what else can we do? We know that AB plus BC is going to be equal to AC. Yes, AB plus BC is going to be equal to AC. So if you want BC, you can write BC as AC minus AB. Now students, quickly pay attention. If you need to find AC and AB, they have to be sides of right angle triangles. Now if you look at this, we already know AB, right? AB is already known to us. So one part of work is done. What we have to find is AC. So look at AC now. We have to find AC. Students, if you look at AC, only focus on AC now. AC belongs to which right angle triangle? ACD. AC belongs to right angle ACD. Do you know any side from this right angle triangle? Do you have a knowledge of any of the sides of this triangle? Because students, if you have to calculate a side, you need one angle and one side. Angle you already have. Angle for the bigger triangle is 60 degrees. But do you have any side? No, right? You don't have any side for this triangle. If you look at ACD, you don't know side AC, you don't know side CD, you don't know side AD. So you don't know any of the sides. That means before finding AC, you have to find an intermediate side. Yes, you have to find something intermediate. Now, remember this till the end of this chapter, students. Whenever you feel that in a triangle you don't have a side, look for the common side between both the triangles. Between both the triangles, when I say that, between the two right angle triangles, we are not concerned with triangles which are not right angle triangles. So we have two right angle triangles out here. Which are they? One is triangle BAD and the other is triangle CAD. Quickly tell me which is the common side between these two triangles. Yes, which is the common side between these two triangles, everyone? Okay, AD. Yes, clearly you can see AD is that common side. Now students, it's extremely easy. Since AD is the common side, first we will find AD. How? From the smaller triangle. Pay attention, in our smaller triangle, which is highlighted for you, you know one side, you know the theta, which is 45 degrees. Is it difficult for us to find the common side AD? No. And like I said, when you have more than one triangles, you can start giving variables. Yes, you can start using X, Y, H as per your convenience, right? So first we are going to find AD from triangle BAD. Another important point, we have only right angle triangles. Before you apply trigonometry, it is imperative to say that you have a right angle triangle. Okay, please pay attention to these small details due to which you can lose marks. Okay, now in this triangle, students, we have an opposite side known to us. We have to find the common side, which is the adjacent side. Ratio has to be tan, right? So we're talking about tan ratio out here. Now, if you have to find tan ratio, tan we know is opposite upon adjacent, AB upon AD. Tan 45 we know. Yes, students, what is tan 45? Quick. Yes, it's 1. Yes, Prathamesh, excellent. That's correct. Tan 45 is 1. Yes, so we have 1 is equal to AB upon AD, 20 upon AD. And students, pay attention, whenever you have tan 45 ratio, the two sides are going to be equal, right? Because if you pay attention in a right angle triangle, if one acute angle is 45, the other acute angle is also 45. If angles are congruent, it becomes an isosceles right angle triangle. sides also have to be equal. Yeah, but you need to apply trigonometry for that. Don't start getting into isosceles triangle theorem. So what we know is AD is 20. Once you get the common side, now it's extremely easy. You need to calculate AC, and AD is known to you. So quickly apply trigonometry in triangle ACD. You can write AC as 20 plus x, or if you don't want to write it that way, directly find AC and then subtract 20 from it. If you write it as 20 plus x, when you solve the equation, you will directly get the value of this unknown, which is x. So it's your call. It's not difficult. Even if you calculate entirely AC, subtract 20 from it, and there you go. You'll find the value of BC. So let's get started with our work. Now, in the bigger triangle, let me highlight that for you. Okay. So in the bigger triangle, we know theta is 60, AC is the opposite side, AD is yet the adjacent side. So again, the ratio is going to be opposite upon adjacent tan. Tan 60, students. Quick. What is tan 60? Tan ratio, tangent ratio of 60. Yes, it's root 3. That's correct. Reciprocal of tan 30, that is, which is root 3. So what we have is tan 60 is AC upon AD. Let's quickly substitute every bit that we know. Right now, we are going to consider AC as 20 plus x. So we're going to substitute that as well. So root 3 is 20 plus x upon 20. Let's quickly cross multiply. 20 root 3 is 20 plus x is 20 root 3 minus 20. You can always take common, students. Taking common makes your life easier. Okay, it's not a hard fast rule, but taking common definitely makes your life easy. So we take 20 common. What remains in bracket is root 3 minus 1. Now is the time to substitute the value of root 3. 1.73 minus 1, which is 0.73. Just multiply, and there you go, 14.6 meters. Yes, so you have directly got the value of x. That means you have directly got the height of the transmission tower, which is 14.6 meters. Make sure you write your units everywhere. That means you write them here as well, and obviously here as well. All right, so make sure you write your units properly, you write your statements properly, and you should be getting full marks then. All right, any issues with this sum? This is the first sum where we have dealt with a common side. Going forward, whenever you feel that there are two triangles and there is inadequate information, look for the common sides. All right, look for something that is common and take the ratio with the common thing and the known thing. Yeah, or common and the unknown. You can always do that. Okay, let's move ahead. Let's look at the next question. Okay, so the next question, it's slightly similar, but the calculations become really different. We'll see why. Now, in this, what do we have? We have a statue 1.6 meter tall. Don't be in a hurry to draw everything till you read the statement. This statue stands on the top of a pedestal. Now, students, pedestal is nothing but a structure which gives some height, right? Pedestal is at some height. So basically, first we have a pedestal, and on that pedestal, now a statue is placed, right? You must have seen a lot of statues. Statues are not directly placed in the ground most of the times. So we have a pedestal and then a statue. So we're going to name all these points. Let's say our pedestal is AB and the statue is BC. What else do we know? The statue is 1.6 meters tall. That means now BC is 1.6 meters, right? What else? From a point on the ground, the angle of elevation of the top of the statue is 60. Top of the statue means from point C to the point on the ground, theta is 60 degrees. Okay, what else do we know? And from the same point, so the point of observation is same. Now we are going to look at the top of the pedestal. So from this point to the top of pedestal, obviously the angle is going to reduce, and now the angle is 45 degrees. Okay, so I'm just gonna write it outside for convenience. This angle is 45. Let's just complete the rest of the figure. It's incomplete without drawing this line. So I've joined AD. What do we need to find? We need to find the height of the pedestal. We need to find AB. All right, okay. Now let's see what we need to do. Before that, let's look at the diagram. Now you need to look at AB. Students, if you pay attention, if you look at AB, AB belongs to a right angle triangle. Which is that triangle? It's triangle BAD. But there's one small problem with BAD. In triangle BAD, you don't know any of the sides. You don't know AB, BD, AD, none of the sides are known. All right. So that means we first need to go to the other triangle. But which is the other triangle? Other triangle is CAD, right? The other right angle triangle is CAD. Do you know any sides of CAD as well? No, we know nothing about BAD. We don't know any sides of CAD. All we know is AC is AB plus 1.6. So we don't know any sides of CAD as well. In this case, also, you need to consider the common side. The common side is going to be extremely helpful. But now pay attention how the common side is going to be used. For the first triangle, we are going to take a ratio of what you have to find with common side. Yes, in your second triangle, again, you're going to take a ratio of something that you slightly know, that means AC. Look at AC. You know one part of AC. And AC is AC plus AB again upon the opposite side. Now, students, pay attention. If I say some A is equal to AB upon AD, and I say B is equal to AC upon AD. Okay, just per se, this is some ratio A and B. Now, if I say A is AB upon AD, can I say AD is equal to A upon AB? Yes, I can say that, right? AD is equal to A upon AB. And once I know this value of AD, what I can do is substitute this value of AD in this place. Students, I can quickly substitute the value of AD in this place, and that is how what yes, that's when you do this, what happens is you get rid of the unknown quantity and you can equate the two ratios. Yes, you can equate the two ratios. That's exactly what we are going to do. So in this case, our common side will be used to find the unknown. Yes? Okay. Now pay attention. Quickly, two right angle triangles without thinking anything. First, let's take the two ratios. With whom? With our common side. Now, in the small triangle, definitely first thing is we have to find AB. And second thing is the common side. So the ratio has to be AB upon AD. Quickly, students, AB upon AD is which ratio for theta 45? Yes, come on. What's the ratio of AB upon AD for 45 degrees? Yes, Yuvraj, that's correct. It's tan ratio. So quickly take tan 45, and we already know that tan 45 is 1. So like I said, whenever you have tan 45, the two sides are going to be equal. So if I take AD as X and AB as H, what I understand is X is equal to H. Yes, students, tan 45 is 1. So X is equal to H is what you understand. Now, this is the ratio from the first triangle. Let's look at the next triangle. In your next triangle as well, one side always has to be the common side, and the other has to be the side which contains what you have to find. Students, pay attention. What you need to find is a part of AC. So your ratio has to be AC upon AD. Again, it's opposite upon adjacent, so you need tan ratio. This time tan 60 is root 3. Root 3 is, look at what we have. AC is H plus 1.6, H plus 1.6 upon AD, which is X. But if you have one equation, you cannot roam around with two unknowns, right? If you have one equation, you just need one unknown. So what are we going to do? From this one, you will replace X with H. You will replace X with H or H with X. It doesn't matter because they are equal to each other. But for simplicity, since we have kept AB as H, we're going to leave H as it is and we will replace X with H. That's the only reason why we have chosen to replace X with H. Now that's it. So what we have? First, we have cross multiplied. So root 3x is h plus 1.6. Time to replace x with h. So root 3h is h plus 1.6. Students, pay attention. Basic algebra rules follow. Similar quantities go on the same side of the equation. Shift this h on the other side. Plus on the other side became minus equal to 1.6. Now, if you pay attention, root 3h minus 1h, directly you cannot subtract. So let's try to take common, right? That's the place where taking common helps. We took h common. What remains inside is root 3 minus 1. 1.6 upon root 3 minus 1. Yes, we have taken this, multiplication becomes division. Now, pay attention. If you substitute root 3 minus 1 out here, let me tell you what happens. Root 3 minus 1 would become 1.6 upon 1.73 minus 1 equal to 1.6 upon 0.73. Unless you're fond of long calculations, do not do this. Yes, do not do this. So what we are going to do is, since you have an irrational equation now, it's not just an irrational number, it's an expression, right? It's an expression. So again, we rationalize, we'll multiply and divide by the conjugate of this. Yes, what's the conjugate of root 3 minus 1? Conjugate of anything is the same two the same two terms from your expression with the opposite sign. So if you have minus, minus becomes plus, and plus becomes minus. So this is known as the conjugate. And now instead of rationalizing, we multiply and divide by root 3 plus 1, root 3 plus 1. Is that understood? If you look at the denominator first, a minus b, a plus b. That's the whole point of doing conjugate, so that you get a square minus b square. So whenever you have conjugates, you will always have a square minus b square in your denominator. Numerator, directly just multiply 1.6 into root 3 plus 1. Now I believe this is 3 minus 1, which is 2. And in the numerator, now cancel what you can, and now you can substitute the value of root 3. I'm not going to get into the details of calculations. The rest multiplication can be done. Yes, so do not substitute for root 3 unless and until it is in the numerator. Otherwise, you're just going to make your life difficult. All right, so never do that. Okay, directly we've got h, and that was the height of the pedestal. So we got what we want, hence the result. All right, any issues with this sum? So you must have understood how different this sum is from the previous one, though there's only a slight change. Yeah, so in this sum, here common was taken so that you could equate the two equations, whereas in the previous sum you found the common side so that with the help of this you could find the other third side. But in this case, common is used only so that you can equate the two values. So I hope you have understood this sum. Now since you have already understood the basics, it'll be very easy to solve the further sums. Let's quickly look at the next sum. This is going to be the last sum for our session. All right. Okay. 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 Someone raised the hand. I'm not very sure how you pronounce your name, so I'm just gonna keep it that way. But since you don't have a question, it's all right. Okay. Students, if you raise your hand, you can type a question. There's an option to type a question, so you can ask your query out there or in the chat box as well. Okay. So we move ahead. Angle of elevation of the top of a building from the foot. All right. So angle of elevation of the top of a building from the foot of a tower. Students, if you pay attention, we have a building and a tower. We have a building and a tower, two structures which are vertical. That means now you have two vertical lines. First, let's just create two vertical lines. It doesn't matter if you create them equal or not, but depending on what we have, we will decide which is bigger than the other. Students, from the question itself, you can understand who's the bigger one. Okay, pay attention. Angle of elevation of the top of a building from the foot of the tower is 30 degrees. All right, so building to the tower is 30 degrees, and angle of elevation of the top of the tower from the foot of the building is 60 degrees. Now, students, if you pay attention, obviously, there was a theorem, right? Side opposite to smaller angle is smaller, and side opposite greater angle is greater. So if you pay attention, 30 degrees is the smaller angle and 60 degrees is the bigger angle. So this is definitely going to be 30 degrees for me. Yes, this is my 30-degree line. And what is this 30 degrees angle of elevation of top of building to the foot of tower? That means this is the top of the building. This structure has to be my building. Okay, so pay attention. This is my building. Definitely that means the tower is the longest side. And what is said? Angle of elevation of top of the tower to the foot of the building. So now top of the tower to the foot of the building is the greater angle. We already know that, and it's 60 degrees. Don't mind the diagram. We're going to look at a nice diagram now. Okay, so what we already know is AB is the tower. You need to understand this, students. Side which is opposite to the greater angle has to be the greater side. There's a theorem which we have already studied. So this is your tower, and tower is 30 meters high. So now we know AB is 30 meters. Find the height of the building. We need to find CD. Quickly, students, pay attention. CD belongs to which triangle? BCD. Yes, CD belongs to triangle BCD. And if you look at triangle BCD, we know that theta is 30 degrees, but we don't have any side from this triangle known to us. Yes, there's no side known to us. Again, to the rescue, what do we have? We have a common side. Okay. All right. If there is no root 3 value. Okay. So if there's no root 3 value, dear, like I said, we already know that root 3 is equal to 1.73. So I hope I'm answering your question. Root 3 we know is 1.73. So even if it's not given to you, please make sure you substitute. All right. Please make sure you substitute this value and get the answer in a proper integral form. Make sure you don't have any irrational numbers in your final answer. Okay. All right. So we continue with the sum, students. Pay attention. So in this triangle BCD, since there is no side known, we are again going to start looking at our common side, which is BC. Yes, we're going to try and find this common side. And can we find BC from the second right angle triangle? Yes, definitely. BC is a common side, so it also belongs to triangle ABC. Now, in triangle ABC, you know the value of AB, you know theta, which is 60 degrees. It's extremely easy to find BC. Quickly tell me, for triangle ABC, what ratio are you going to consider to find BC? Quick, students, this is the last sum. Let's try to get as interactive as we can. Okay, Yuvraj says tan. All right. Let's see what else do others think. Come on, students, quick. Okay, tan. All right. Okay, Prathamesh, yes, tan, that's correct, students. Yes, so definitely again we're doing the same thing, right? Now y'all must have also got bored. It's like the same thing. It's so easy. It's opposite upon adjacent because one is what we know and the other is the common side. So let's quickly take that ratio from ABC, tan ratio. So first we find tan 60 is root 3 is 30 upon BC, 30 by root 3. Yes. Now students, you can leave it this way because it's the intermediate one, or there's no harm in rationalizing this because we know that 3 in the denominator is going to get cancelled with 30. So now there's no harm. You can rationalize this and get the value as 10 root 3. Do not pay attention to what I say. Do not substitute the value for root 3 out here because BC is not we were aiming to find. Yes, so please do not substitute your value out here. Values will be substituted only in the final answer. Quickly now, students, BC is 10 root 3. Now it gets so easy, right? What you need to do is apply trigonometry again in your next triangle. Again, opposite side needs to be found out. Adjacent side is known to us. Yes, like others have already found. Okay, I've got smart people out here. Quickly, apply tan ratio. Tan 30 is now DC that we need to find upon BC, which is the common side. Look how helpful our common side is, right? So let's quickly see. 1 by root 3 is DC upon 10 root 3, and you could cancel root 3 and root 3 right here, right? So which is why you don't substitute the values. That's it. DC is 10 meters and that's the height of the building, 10. All right, students. So we're done with our lecture for today. We'll continue this in the next session. I hope you enjoyed the lecture and you, by now, the basics of applications of trigonometry are like done for y'all, right? I hope you all have understood how to take ratios and how to draw diagrams, most importantly. Yes, thank you, Prathamesh. Thank you so much. You're most welcome. All right. Okay, thank you, everyone. Hopefully, I'll see you all in the next lecture and we'll continue with some more slightly complicated sums in the same section. Okay, all right. Thank you so much, people. Yes, all right. Okay. So signing off for today. Bye, people.